Okay, now let's go to the inverse Laplace transform using partial fraction. Okay, so previously you have seen a few examples that involve fractions, which can be written into expression that we have in the table of transform by a little bit of manipulation, right? Okay, what about you have if you have this kind of function 3s plus 1 over s square minus s minus 6. So how can we rewrite the fraction? So you cannot solve it as usual like in previous video. So you have to do some calculation on for the denominator, because at the denominator we have a quadratic function, right? We have s square minus s minus 6. So to solve this one, you have to use partial fraction. Okay, you have to use partial fraction. So this partial fraction actually you have learned before, so I won't cover partial fraction in this video. I'll just go to the inverse Laplace transform. Okay, so let's say you have s plus a gives a partial fraction of a over s plus a, right, where a is constant. So if you have s plus a square, this is all at the denominator when s plus a at the denominator. Okay, so when you have s plus a squared, then you will have s plus a, another one is s plus a squared, and for the constant you have a and b for the numerator. If s plus a cube, then you have a over s plus a plus b over s plus a squared plus c over s plus a cube. Okay, if you have quadratic factor s square plus bs plus q, then for here you have s square and s, right? So you will have s here. Okay, ps plus q or as plus b over s square plus plus ps plus q. Okay, so if you are using a and b, then here will be a and b lah. So repeated quadratic factor s square plus ps plus q square gives ps plus q over s square plus ps plus q. Another one will be another constant, which is rs plus t, and this will be s square plus ps plus q square. So if you confused with this partial fraction, please do some revision on partial fraction. Try to Google it or watch video on YouTube. Okay, so by doing that, then you can understand better for the partial fraction. So we go back to the question just now. You have 3s plus 1 over s square minus s minus 6. This one you can factorize, right? So when you factorize this s square minus s minus 6, you will get s plus 2 s minus 3, okay, for the denominator. So you use partial fraction, this actually will be your a and b. Okay, here you can refer here. So a over s plus 2 plus b over s minus 3. Then you do you solve for a and b. You will get a equals to 1, b equals to 2. Okay, so you will get the new function, which is 1 over s plus 2 plus 2 over s minus 3. So you will have the new function of this. So this is actually mapped to 1 over s minus a. So your fs is 1 minus a. So your ft will be e to the power of at. This is from the Laplace table, okay, that you have learned at the beginning of the chapter. Okay, so here we separate this to inverse Laplace. So for here you have 1 over, it is actually the Laplace, the inverse Laplace of 1 over s minus negative 2 plus 2, you take out 2, okay, because 2 is constant, 2 times the inverse of 1 over s minus 3. So here your a is negative 2. So you will get e to the power of negative 2t plus 2, because of this 2, times e to the power of 3t. So that's why you get this answer. Okay? Okay. Tips when dealing with fractions. So if the denominator is a quadratic equation is when the highest degree is 2, try to factorize the denominator first. If it is possible, then proceed with partial fraction. If not, then you have to do the completing the square method in order to get the fs minus a function. Okay? Okay, example 9. Determine the inverse Laplace of 5s plus 1 over s square minus s minus 12. Right? So 5s plus 1 over s square minus s minus 12 is equals to, the denominator here you can factorize, so it is equals to s plus 3 s minus 4, right? This is 5s plus 1. Okay, so it is equals to a over s plus 3 plus b over s minus 4. Okay, so by using partial fraction, okay, by using partial fraction, you will get later a is equals to 2 and b equals to 3. Okay, please do some revision on partial fraction if you don't remember this partial fraction. Okay, so from this partial fraction, you will get a equals to 2 and b equals to 3. So the inverse Laplace of 5s plus 1 over s square minus s minus 12 is equals to the inverse Laplace of 2 over s plus 3 plus 3 over s minus 4. Right? So this is equals to the inverse Laplace of 2 over s plus 3 plus the inverse of 3 over s minus 4. Okay, so this is equals to, these two you take out, and then you just left with the inverse of 1 over s minus 3. Okay, plus 3 inverse Laplace of 1 over s minus 4. For this function, your a is negative 3, so it is equals to 2. So if you have this 1 over s minus a, this is your fs, so your ft will be e to the power of 80. Okay, so this one is e to the power of negative 3t plus here is 3, and for this function it is e to the power of 40. So the inverse Laplace of this function is equals to this one. Okay, okay, now example 20. Determine the inverse Laplace of this function. Alright, now by using partial fraction for s square minus 5s plus 6 over s plus 1 s square plus 4 equals to a over s plus 1 plus for s square, here you have s square plus 4, right? So here will be bs plus c. Okay, so by using partial fraction, you will get a equals to 3, b equals to 1, and c equals to negative 6, right? So the inverse Laplace of s plus 1, s square plus 4 for s square minus 5s plus 6 equals to the inverse Laplace of 3 over s plus 1 plus the inverse of s minus 6 over s square plus 4, right? So here you will have 3, the inverse of 1 over s minus negative 1. Here your a is negative 1, okay, plus, okay, for this question we need to separate s and negative 6. So plus inverse of s over s square plus 4 square, 4 square, it is actually 2 square, okay, minus 6, I'm sorry, okay, minus the inverse of 6 over s square plus 4. Okay, this is 3. If you have 1 over s minus a, then it will be e negative t, plus if you have s over s square minus plus 4, so s over s square plus a square, this is actually cos at. Okay, so this one, if you have number up here, so you have a over s square plus a square, this is sin 80. Okay, this one is cos a is 2 in this case, a is 2t minus, for this one, inverse of, this is s square plus 2 square, right? So 2 square is equals to 4, so 2 will be here, 2. In order to get 6, you have to multiply by 3, so this 3 is constant, you take out 3. Okay, so you have 3e negative t plus cos 2t minus 3, you take out 3, and it will be sin 2t. Okay, so this is the answer. Okay, now let's go to the next question. Determine the inverse Laplace of this function. Okay, for this function, for the denominator here, you cannot factorize. Okay, you cannot factorize into 2 bracket. Okay, so in order to solve, you have to use completing the square techniques. So I'm not going to cover completing the square in this video. You have to refer to your reference book or Google or YouTube to refer to recall back how to use the completing, how to do the completing the square. Okay, so this s square plus 2s plus 17 is equals to, by using completing the square techniques, you will get x plus 1 square plus 16. Okay, so the inverse Laplace of 2s minus 3 over s square plus 2s plus 17 is equals to the inverse of 2s minus 3 over s plus 1 square plus 16. Okay, so in this function you have s plus 1, which is you have actually s minus a function. Okay, at the denominator you have s minus a, but up here at the numerator you don't have s plus a or s minus a. Okay, so you have to do some rearrangement in order to have s minus a at the numerator and denominator. Okay, because this is mapped to the inverse of f s minus a, because we have this s plus 1 here, right? So 2s minus 3 over s plus 1 square plus 16 is equals to, now I want to do a rearrangement at the numerator. Okay, so I take out 2 and then bracket s plus 1, because I want to have the same s plus 1 at the with the denominator here. So what should I put at the back here? I have 2s now plus 2. So how to get minus 3? So I have to put minus 5, right? So when I have 2s plus 2 minus 5, then only I can get 2s minus 3, right? The same as this one. Okay, now so I now have the same function of s minus a plus 1 square plus 16. Okay, so from here it is equals to the inverse Laplace of 2s plus 1 minus 5 over s plus 1 square plus 16. Okay, now my f s minus a is equals to 2s plus 1 minus 5 over s plus 1 square plus 16 from this function. This is my f s minus a function. Okay, so I want to have the fs function, because if it is mapped to inverse of fs minus a, so this s minus a is equals to e to the power of at ft, right? So I must get the ft function in order to solve this question. Okay, so from this my a is equals to negative 1. Okay, my a is negative 1, so my fs now is 2s minus 5 over s square plus 16. Right, so I have to get ft function. So ft is equals to the inverse of fs. So it is equals to the inverse of 2s minus 5 over s square plus 16. So this is equals to the inverse of 2s over s square plus 16, right? I separate these two functions, minus the inverse of 5 over s square plus 16. So here I take out 2, so I have s over s square plus 16. So this is cos 80 minus, and this will be sin 80. Okay, this is s square plus 4 square. So this one should be 4 here. So you will have 5 over 4. Okay. So 2, this is cos 16 is 4 square. So it is 40 minus 5 over 4 is constant, 5 over 4. This is sine. Oh, I'm sorry. Wait. Oh, right, correct. Okay. So sine 40. Okay. So this is for this function is ft. Okay. So this function is equals to the inverse function, the inverse Laplace of 2s minus 3 over s square plus 2s plus 17 equals to e to the power of a is negative 1, right? A is negative 1 so a is negative 1, so it will be negative t, and ft is 2 cos 40 minus 5 over 4 sine 40. So this is the answer, right? Okay, so I'll leave you with past year test 2 as your assignment as usual, as your assignment for chapter 3.5 part 2, right? And you have to submit in the e-learning as usual. Okay, so this is the question. Right. Okay, so I'll stop here. In the next video I will teach you on the inverse of Laplace transform by using convolution theorem. Okay, so that's all for this video. Thank you.